SwayamPrabha. Digital India. Educated India.
So welcome to this session. We are here to share our experience and some stories about medical device innovation. In particular, we will answer 4 questions. Why do we need new medical devices? Number 1. Number 2, how can we develop and commercialize those devices, specifically in an academic setting, students and faculty and so on. The third thing is, are there any examples of indigenous medical devices which have actually reached the market? And fourth is, what are the best practices, some tips to create maybe success stories in this field. Okay, so these 4 we'll answer. But let me start with this slide, which shows that Indians are innovative. You have to just go on to Google and say India and Jugaad, and you will find many examples of Indians being very innovative. Whether it is shaving without a mirror, peeling onions without getting tears, whether it is making lassi in washing machines, or whether it is putting truck tires on bullock carts. And one more innovation, which is the Jaipur leg. One common factor in all the innovations is that there are no engineers involved. Even the first picture is a brother of an engineer, not an engineer. Okay, so if there are no engineers involved and there is a raw innovation capability in Indian public, how come that today when we go to market and look for some mass-produced technology products, there's not a single Indian company to be found worldwide? You may find some Indian companies selling in India, but can you find Indian products across the world? Consumer goods, mobile phones, TVs, defense, transport, industrial machinery, and medical devices. Very few. At this point of time, we are just importing. The reasons for that are that it is not so easy to take an idea from a research lab into industry through the commercialization pathways. We say that there are 4 valleys of death. The first valley of death is just your idea in the head, putting it on the table in the form of a proof of concept. It could be just clay and paper and some thread and tubes and things like that. If you cross this valley of death, the next one is to create a prototype. Now that is also not so difficult to do it in research labs, because it's some 3D printing, maybe it is some PCB, maybe it is even breadboard. You can do these things in lab these days. The problem is taking the prototype into the market through a product. Converting prototype into product is not easy. Neither academics know the game, nor industries wants to take risk into that. Okay, there is a body of knowledge which is required to convert prototype into product, which neither academics nor industry have that. But if you can somehow cross that third valley of death, the rest of the game is very well known to industries. How do you get government permissions? How do you raise money? How do you get land? Hire people, get equipment, distribution, sales channels? They know the game. So why is this not happening? Okay, one other reason it's not happening is that academics think that if they got an idea and maybe made a POC or maybe made a prototype, maybe wrote a paper, or in the great case published a patent, they think the job is over. They think half the job is over. It's not really so. Actually, it is the other way around, that idea generation is very easy. You and me can sit for next half an hour and generate 30 ideas just like that. But taking the ideas all the way to commercialization is actually very difficult. And until academics realize the importance of commercialization, this is not going to happen. It's not even 10, 20, 30, 40. It's actually an order of magnitude. You can build a prototype, POC for a few thousand rupees, prototype for a few tens of thousands of rupees, but it keeps on growing 10 times as you go to next stages of product life cycle. So it is not easy. It's expensive. So what is the status of Indian industry today? I'm sure you are reading the papers that Indian industry is not doing so well. Sector after sector are either collapsing or not doing very well. You must be hearing that. Okay. The reason is that at this point of time, we are neither able to compete with the quality of Western countries, nor can we compete with the Eastern countries, China, Vietnam, Thailand, increasingly even Bangladesh, they are much better manufacturers of textiles now. Right, number 2, right after China. Okay, so we're not able to compete when it comes to cost with these Eastern countries. And government regulations, of course, is always a bottleneck, although they're trying to do ease of business. So the only way to do is to innovation, and there are some drivers there. Because customers are not loyal. Today you buy Samsung phone, tomorrow you have some other company offering better features as less price. Are you going to be loyal to Samsung? Most probably not. Maybe there are some die-hard Apple fans, but that's about it. So we can say maybe that we lost the game, okay? But having said that, there is a silver lining in the horizon, in the sense that there are this whole host of new technologies, whether it is 3D printing and CAD/CAM, whether it is sensors and Internet of Things, whether it is medical imaging or imaging in general, image processing, artificial intelligence and machine learning. These are giving us a chance to rethink, reinvent products from scratch, to give better features and better quality and lower cost and so on. So the only way ahead actually is innovation. But please, as I keep mentioning all the time, innovation is not specific to a specific discipline. You cannot say a product is mechanical or electrical or electronics or software. You need all the branches and the domain discipline. If the product is for medical, you need doctors in the game. If the product is for agriculture, you need farmers in the room. So you need to have domain expertise also. Okay. So having understood the whole reason and all that, do we have the ecosystem for innovation in India at this point of time? If not, how do you go about building the ecosystem? That is a question we want to answer. So let me say that if you want to pick and choose which areas you want to start the innovation game rolling to build the ecosystem, and young people actually have come up with, of course, consultation from all the countries and everyone else, politicians, saying the world at this point of time needs to focus on 17 sustainable development goals. These actually give us a very good starting point, and a lot of young people are actually concerned and thinking about careers in these domains. So if you think about these 17 SDGs as a starting point, where do we pick and choose? And I would like to say that let's think about healthcare as a starting point, because healthcare and innovation and life on land is 3 out of 17. And I'll give you 4 reasons for doing that. Reason number 1 is that at this point of time, medical devices are badly needed for taking care of both diagnosis and treatment of various diseases. How many diseases? 14,000 as per WHO. Okay, so you need a variety and army of devices to diagnose, screen, monitor, treat, rehabilitate, assist patients. And what is the current scenario? The per capita expenditure on healthcare in India is less than 1% of that of USA, and USA is world's both largest producer as well as consumer of medical devices. So even if you take a made in USA device and give 90% discount, it is still 10 times more expensive than what can be afforded by average Indian public. Reason number 2 is that healthcare has a great social impact. If you can lower the cost of not just device, but the cost of treatment or diagnosis to, let's say, 1%, and it is feasible. If you can somehow lower the cost to 1%, it's a great opportunity to reach out to large number of population at the bottom of pyramid. Those who are especially unprivileged, if they fall sick, they lose 1 day's wages. There's 1 day's income not there, 1 day's food is not there on table. So if they cannot afford to fall sick, we need to make sure that they don't fall sick or are diagnosed in time. As per some reports, healthcare has become the largest employer in USA already, and healthcare startups are number 2 among all startups in India at this point of time, right after e-commerce. Even in Sign IIT Bombay, now out of 20 odd companies, apparently half are healthcare startups. So startups are giving a lot of employment opportunities as well. The third reason is that at this point of time, there are fantastic funding avenues available from various government bodies, apart from NGOs and private sector. If we just take one government arm itself, which is BIRAC, which is an arm of Department of Biotechnology, which is an arm of Ministry of Science and Technology, just one arm of an arm, you can say one finger of government, has so many schemes. I have listed only a few, including the famous BIG or Biotechnology Ignition Grant. And BIG grant of 50 lakh rupees or 5 million rupees is given directly to an innovator or a startup company to start a company and take a product to market. Equity free, you can say, grant. They're not going to take any shares in the company. It's a pure equity free grant. And there are, of course, a large number of bio incubators and Atal incubators where you can actually go and start these companies. Reason number 4 I saved for the best, which is you cannot do innovation unless you do collaboration. You can't do collaboration unless you go out of comfort zones. Okay? And at this point of time, bio combined with any domain, you cross bio with any domain, as you can see here, biophysics, bioelectronics, biomaterials, and biotechnology itself has several colors. Okay? Not only potential for research, but also potential for practical applications. And nothing like biomedical, because if you want to collaborate and go out of comfort zones, the test of that is, can you ask stupid questions to each other? You can't have ego there. And it's easier to let go of ego when you're trying to solve the problem of someone in pain or someone suffering. So it's easier to collaborate in healthcare domain, coming across various disciplines because of this factor of social impact as well. Let me come to what we are doing at BETIC. So BETIC is a lab inside IIT Bombay. It's an R&D project funded by the state government of Maharashtra and central government of India, Department of Science and Technology. And it started with a very simple theme. We said, let us just bring the stakeholders together. What stakeholders? Doctors, researchers, entrepreneurs, and investors. These are the 4 critical stakeholders for medical device innovation and commercialization. Simply just we said, let's get them together, okay? And magic will start. So what we have inside the lab are several different small cells, you can say. We have one cell for generating ideas or where doctors meet us. We have one cell for doing CAD and simulation, one cell for doing plastic prototyping, one for electronics prototyping, including electronics CAD, simulation, and PCB milling, and one for metal 3D printing. Plus, we also have access to testing labs across IIT and so on. That is at IIT Bombay. But BETIC is also in other institutions. One partner is VNIT in Nagpur, where they have tissue engineering facilities. You can 3D print materials which are bone-like substitutes, and you can use them to fill gaps in human body, especially bone gaps. We also have a BETIC cell in College of Engineering, Pune, where they're focusing on 3D printing and electronics. And we have a gate lab where you have cameras on the ceiling and on the floor, by which when you walk, we can capture 3D movement, which can be used to create a, you can say, stick diagram or force model diagram of human body. Where you walk is a signature of not only your skeletal problems, but also it's a signature of your neurological problems. Your walking signature can tell a doctor what you are suffering from. So we have the lab for doing that also. Then we put a process in place for innovation. And this process, if you can see, has 4 major stages. Stage 1 is called define, where doctors play a critical role. Stage 2 is called as develop, where researchers play a critical role. Stage 3 is called as deliver, a tested device, where entrepreneurs play a role. And the stage 4 is to deploy in practice, where investors are necessary. What we did was to divide each of these stages into 4 steps each. So you have 16 steps. So the define stage has 4 steps. Build a team, go and watch what is happening in hospitals, define the problem that you want to solve, and then create a concept and then check the feasibility of the concept right at the early stages before you invest more effort and money into that. Then you get into the development stage where you are actually looking at detailed design, virtual or CAD modeling, then rapid prototyping and functional prototyping. Then you have the deliver stage where testing has to be coming into picture. This is where most of the academics give up. They think that development is over, we can file a patent or publish a paper and our job is over, someone will take it forward. Usually no one takes it forward. You are the mother or the father of the idea, so it's your responsibility to nurture the child beyond that. Testing is one critical phase like that. So you have to actually figure out how to test it in the lab, how do you test it in the, how do you manage the quality systems before you do testing, what standards you have to follow, then lab testing, then you have clinical trials, preclinical trials, main clinical trials, and finally certification of the device. Unless you have certification, you are not able to, you can't go forward into manufacturing that. Then the last stage comes where you have to deploy the device into market. So here we have the IPR, intellectual property rights. You have to create a business model. How are you going to sell the product? Through what channels? what is your supply chain, distribution channel, all those things. And then you look at where do you get the funding for initial and then scaling up, sustaining the activities. And life is not over. Once you're version 1 in the market, you go and build version 2 and version 3 and so on. No one builds a perfect product which is stable forever. Now, usually people say that the innovation game is very risky. Okay, if you have, you start with 10 ideas, you go for one prototype, 10 prototypes, one becomes a product, 10 products go to market, one will be breaking even. For 10 which break even, maybe one will make fantastic or huge profits. They say 10,000 is to 1 success ratio. But be careful when people say that or you hear this statement. When you're talking about idea stage, I mentioned to you earlier that we can sit for 1 hour and we can generate 100 ideas if you wish. Now, what is the cost per idea? Hardly anything. Maybe some tea and coffee. Okay. Out of 100 ideas, we decide to take forward only 1 or 2, and I say 90% failure rate. Does it sound like a good thing or a bad thing? It's a good thing. You tried 100 with at a hardly any cost, threw away 98, and you're taking 2 forward. So as you go forward in the life cycle of a product development, initially you can throw away a lot of ideas, but it doesn't cost you anything or very little thing. And by the time you come to the final stages that the product is actually manufactured and put into the market, you better be very sure that it will break even at least, if not make you a handsome profit. So actual success rate or actual failure rates are not high as they say. The real cost of failure is not really that high. Okay, if you do things in a systematic way.